Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 3. We're continuing our discussion of trigonometry. And today, I would like to talk about solving systems of equations involving circles. So, we talked about how circles have a general form. Here's our equation of a circle. So we know that for this circle, the center is going to be at the point HK, and we have a radius equal to R. Alright. Now, the question before us is, what are the possible situations where you have, say, a circle and a line intersecting each other? So we're considering a situation where you have a linear line and a circle. And so if we imagine our circle here, it is possible that we can have some linear line intersect it like so. And so we have 2 points of intersection. Or we can have a line intersect at a single point right here, and that single point, well, when we have a line like this where it's intersecting at a single point, this is going to be called a tangent line. This is going to be a very important idea that's developed later in calculus. Lots of good things there. And a third possibility is we have a circle and a line, but they don't intersect. So if we're given the equation of a circle and a line, we can algebraically solve to figure out what these points of intersection are. And so in our first situation right here, with the line and 2 points of intersection, if we were to work this out algebraically, we would get 2 points of intersection, so that means there's 2 solutions to the system. Whereas here with the tangent line, there's going to be 1 solution. And for this case over here, since they don't intersect, we have no solution. So this is kind of the geometric explanation of what we're going to be doing. And it's also possible we can have 2 circles, right? So we can imagine a system with two equations of just 2 circles. So let's see, we can have a circle and say another circle here. This will be an example of also 2 solutions, though my circles really do not look like circles, so we can have this as a possibility. You can just use Desmos to do some graphs and find that this is easily so. Another possibility is kind of like the tangent line. We get our single point of intersection, so this is 1 solution. And we can also have the case where you just have 2 circles hanging out, they don't intersect, so this is no solution. We should space that out a little bit, no solution. Alright, scribble, scribble, scribble. Alright, now there's a third possibility, however, or I mean a fourth. We already did a third possibility. So if I have a circle here, it's possible to have another equation of a circle that goes right over this one. So let's see how well we can draw right over it. And when you have a circle on top of a circle, then we have infinite solutions, right? Because it's the same circle. So every point on this circle is a solution. So infinite. Alright, so that's the geometric idea of what we have going on, is these 7 cases here. And now what we want to do is consider how to solve these using algebra. So what do these look like? So for our first example, let's see here. What we're going to do is look at this system right here. Okay. So we have x minus 5 quantity squared plus y plus 2 quantity squared is equal to, what is that equal to? 4. Alright. And we have a linear line of y is equal to x minus 9. And we can see right off that we have 2 points of intersection. It's fairly easy just to plug into Desmos and you can just click and figure it out, but we're going to do the math, right? Because that is the lazy man way, and it's good to prove things and actually work it out yourself. It's a good exercise for ordering your mind. Alright. So when I look at this, I notice that I already have y is equal to something. So I'm going to substitute that right in here. So I have x minus 5 quantity squared plus x minus 9 plus 2 quantity squared is equal to 4. And so I can square the first here, this one. This is just going to be x squared minus 10x plus 25. And we need to figure out what's going on here. Well, we have x minus 9 plus 2, so that's the same thing as x minus 7 squared. So this is the same thing as x minus 7 quantity squared. So if we square x minus 7 squared, that's going to be x squared minus 14x plus 49. All this is equal to 4. And let's go ahead and simplify this a little bit. So I'm going to look here. I got x squared terms here, so I'm going to combine those. My x terms I'm going to combine. And my numbers I'm going to just combine the terms without any x as the constant. So we get 2x squared minus 24x plus, let's see here, 64 is equal to 4. And I'm going to double check my math. Alright, 74. That's why I double checked my math. I was not liking that. Alright. So we have 74 here. Yeah. Alright, so now what we need to notice is that we have a squared here. That means it's a quadratic equation. And we want to subtract this 4 over. So I am going to subtract both sides out 4. So we get 2x squared minus 24x plus 70 is equal to 0. And now I need to divide by 2. I want to divide by 2 because I notice now I have a 2 here. We have a multiple of 2 and a multiple of 2. So I'm going to divide that out and get x squared minus 12x plus 35 is equal to 0. Alright, so this is looking good. And note now that we can factor this nicely. This is x minus 7 times quantity of x minus 5, which is equal to 0. And so this tells us that x has to equal 5, 7. Alright. Let's zoom out a little bit. So we have x is equal to 5, 7. But now we need to figure out the y values. So I'm going to take these values and we can plug it into either of these two equations here. It doesn't matter which one. But this one is the easier one because we already have y isolated, whereas this one will require a lot more work. So we have y is equal to 5 minus 9, and we have y is equal to 7 minus 9. That means y is going to equal negative 4, and y is going to equal negative 2. So our answers, when x is 5, y is negative 4, and when x is 7, y is negative 2. And now we can verify using Desmos here. So if we just actually click here, there's our 2 points, 5, negative 4, and 7, negative 2. Alright, so we'll move on to our next example. So if we have x minus 2 squared plus y plus 2 squared is equal to 4. For our next example, let's bring that back up. Or, yeah, we'll just leave it there. So we have y is equal to x minus 10. Alright, so in this case, again, I have the y already isolated. So what I'm going to do is just plug all of this in for y again. Well, let's see what we get. So we have x minus 2 quantity squared plus x minus 10 plus 2 quantity squared is equal to 4. So the first quantity we know is going to be x squared minus 4x plus 4. And the second quantity, this one here, we know the same thing as x minus 8 quantity squared. So when we square that, we get x squared minus 16x plus 64, and that's all equal to 4. Alright. And now we can combine like terms again. Right? So we want to combine the x squareds, the x's, and then the constants. And we're going to also subtract 4 from both sides, okay? Because this is again a quadratic. So we get 2x squared minus 20x plus 60 is equal to 0. And I can divide both sides by 2 again. Let's see here. Alright, so if we divide both sides by 2, we get x squared minus 10x plus 30 is equal to 0. So looking at this one offhand, I don't think this is going to factor. As you can think, we got 2 times 15, 3 times 10, and let's see here, 5 times 6. None of those is going to give us a 10 here added up. Alright, so this is probably not going to be pretty, meaning we have to use the quadratic formula. So the quadratic formula is negative b plus minus square root of b squared minus 4ac divided by 2a. And in case if you forgot what those letters refer to, it's this here, ax squared plus bx plus c. So the a, b, and c are the coefficients for these terms here that's being plugged in. So let's set up our quadratic formula. X will equal, we have negative here and then we have the negative here, so that's going to be a positive 10 plus or minus square root negative 10 quantity squared minus 4 times, notice our a is a 1, so 1 times 30 all over 2 times 1. And we can simplify this now. So we have 10 plus or minus, and we got 2 here. This is going to be a square root of 100 minus 120. Or we can think of this as square root of negative 20. Alright. So if you didn't notice in this step here, you certainly notice here that we have something goofy going on. We have a negative inside the square root. That means there is not a real answer, so we can conclude no solution. And we can verify that with a graph now. So this one is no solution. And that's because we have the negative right here inside. That negative right there tells us no solution because you cannot have the negative inside the square root. And in fact, there is no points of intersection. So that's why no solution also from a geometric perspective. Now, as you can tell right here, our last example is going to be 2 circles. So we have x minus 5 quantity squared plus y plus 2 quantity squared is equal to 4. And x minus 4 squared plus quantity of y plus 3 quantity squared is equal to 4. Now I'm going to work this out in a different manner. We could solve one of the equations, get x or y by itself, and plug it into the other one, but trust me, the algebra on that is horrendous. You do not want to do that to yourself, and it will create a lot of unnecessary work. So instead, what we're going to do is FOIL these out first. So the top is going to give you x squared plus, well, not plus, but minus. So let's see, what is that? Minus 10x plus 25. And then the next one is going to be plus y squared plus 4x plus 4 is equal to 4. The bottom one is going to become, let's see here, we got x squared minus 8x plus 16. And then we have plus y squared plus 6y plus 9 is equal to 4. Alright, so what we're going to do here is something that's kind of sneaky and ingenious, but totally awesome. What I am going to do is I am going to subtract the top equation. I'm going to subtract from this equation this one right here on the bottom. So I'm going to do the top equation minus the bottom one. So what that will effectively do is you have an x squared, and then now you have a negative x squared, so these die. You have a negative 10x and then a positive 8x, so that's a negative 2x remaining. You have 25 minus 16, so that's going to be a 9. That's plus 9. The y squareds die off, which is also awesome. I don't know why I put a y there, or an x right there when that needs to be a y, so let's fix that. Silly me. So then we have 4y minus 6y, that gives you a negative 2y. And then we have 4 minus 9, so that's minus 5, and that's going to equal 0 because the 4's here also die. Alright, so this thing simplified to this, and we can simplify it further. Negative 2x plus 4 minus 2y is equal to 0, or negative 2x. I also don't know why I put a y there. Rip. Alright, minus 2y is equal to negative 4. Now, I can multiply both sides by negative 2. Oh, I mean a negative a half. We want to divide out 2. Alright. So that gives you x plus y is equal to 2. Or we can subtract the x, so y is equal to 2 minus x. Now that's awesome, right there. Now, so the key strategy that we did was we FOILed out all of these, and then we subtracted our two equations, and that gave us a value, or it allowed us to find what y is rather painlessly. And with this rather painless expression, we can plug it back into one of our equations. I'll just plug it into the bottom one. So this 2 minus x is going to be plugged in right here. So then now our work's going to be here. So we have x minus 4 squared plus 2 minus x plus 3 squared is equal to 4. So this is x squared minus 8x plus 16. And then this is the same, this here, right here, this is going to be the same thing as 5 minus x, quantity squared. So then we get plus 25 minus 25 minus 10x plus x squared. Alright. So then, and this is all equal to 4, of course. So now we can combine like terms like normal and do exactly what we did before. So let's get these underlined. And of course we need to subtract both sides by 4. So we get 2x squared minus 18x, and then we got 16 plus 25 is 41, minus 4 is 37. That's not going to factor nicely, so that's tragic. And I'm going to just verify because it's kind of late and I'm a little sleepy. So mental math not as strong. There we go, 37. Alright. So with this one, I am going to use the quadratic formula again. So x is going to equal negative b, so the negative of negative 18, that's going to give you positive 18 plus or minus the square root of negative 18 quantity squared minus 4 times 2 times 37, and all that is going to be divided by, we should make sure we're not going over to the other side, 2 times 2, or 2a. Alright, so let's figure out 18 squared minus 4 times 2 times 37 gives you 28. Alright, so this is going to be 18 plus or minus root 28 over 4. Alright, so 28, if we recall, is 4 times 7. So this is going to be 9 plus or minus root 7 over 2. So what I did was I realized that root 28, same thing as root 4 times root 7, which is 2 root 7. And then I divided a 2 out of the 18 and the 2 root 7, just giving me this here. So this tells me that x is going to equal 9 plus root 7 all over 2, and 9 minus root 7 over 2. Not pleasant values, but not too terrible. Now the great news is that we have to take these values. I think I'll use pink now. I'll take these values and we have to plug them in to figure out what y is. So they are going to go all the way back into this equation. We figure out what y was in relationship to x, so there's no need in using these more complicated equations when we have this nice simple one. So we said that y is equal to 2 minus x. That means y is going to equal 2 minus this quantity. Okay. So let's figure out what that is. 2 minus 9 halves. 9 halves is 4.5. So 2 minus 4.5 is negative 2.5. And that's going to be 5 halves. So we get negative 5 halves minus root 7 over 2. And then our other value is we have y is equal to 2 minus quantity of 9 minus root 7 over 2. So that's going to be negative 5 halves plus root 7 over 2. So the claim then is when x is, when we have x as 9 halves plus 7, root 7 over 2, our y value is going to be negative 5 halves minus root 7 over 2. And similarly, when we have 9 halves minus root 7 over 2, our y value is negative 5 halves plus root 7 over 2. Alright. We should probably figure out what those values look like. So, let's see here. Second root 7 divided by 2. I'm going to store this in memory slot A because we're using that value a lot. Okay. that's an A, so I want to do 4.5 plus A. That's this one right here. So this is going to be about 5.823 comma negative 2.5 minus alpha A. This is about negative 3.823. And then we got 4.5 minus alpha A. This is about 3.177. And then negative 2.5 plus alpha A. And this is going to be about negative 1.177. So the reason why I went ahead and found the decimal values is so we can look at our graph and see if we actually did. We can double check, see if we did this right. So there we go. Let's go ahead and move that over. Maybe we need to zoom out a little bit. There we go. We can zoom in a little bit now. Alright. So looking at Desmos here, there is this point, and here's our other point. So success. We are successful. So if you had me as a math teacher, this would be the answer I would want, these 2 points here. The reason being is because those are the exact values, whereas these decimal values, they're approximations, because the root 7 is a transcendental number. It means the decimal's going forever. And so when you round like this, you didn't give me the exact answer, you gave me a approximation. Okay? So this would be the kind of answer I would be looking for. Alright. The thing to keep in mind with this one here is the fact that we wanted to simply subtract these equations after we FOILed them out. And the reason is that so we can get rid of these x and y squared terms, because that just made life so much easier for us to get a equation by itself in terms of x's and y's. So I'm referring to this step right here. So once we did all this algebra work, we just got y was equal to something rather simple. And that allowed us to do all our other work with relative ease. Keep this technique in mind when you encounter a problem like this. It will save you a lot of time and tears. Alright. If you've enjoyed this video, please subscribe to our channel. Consider supporting us on Patreon. I appreciate your viewership. Thank you for watching and join our math party. And I will see you next time.